Hello, I am Alessio Ferrari and I'm presenting you this paper entitled The Way It Makes You Feel, Predicting Users' Engagement During Interviews with Biofeedback and Supervised Learning. This is a joint work with a team that is almost entirely Italian. We have Daniela Girardi and Nicole Novielli from the University of Bari, Paola Spoletini from Kennesaw State University, Davide Fucci from BTH Sweden, and Thaide Huichapa, who's also from Kennesaw State University and is the only not Italian in the team because she is Mexican. So here you have the paper in one slide. The context that we are dealing with is user interviews to collect product feedback in bespoke software development. So we are dealing with product feedback from users, but not from user reviews, but from direct interviews with the users. The problem is that in these interviews, it is hard to identify user engagement related to certain topics or features. The solution that we are proposing is to utilize biofeedback from a wristband and machine learning algorithms to predict engagement. The wristband is similar to the one that you may use for tracking your sport activity. We validate our proposal through a laboratory experiment, and the results is that certain topics like usage habits, privacy, and ethics are highly engaging topics with respect to other ones, and our algorithm outperforms a random predictor by 22% in terms of valence and 46% in terms of arousal. These two terms will be clarified later on, but are ways to represent emotions and, in our case, engagement. The contribution of this work is that we are providing a methodology for the identification of user engagement, and although this study is mostly exploratory in nature, there are several applications. For example, the identification of relevance of certain features based on the engagement of the subject, but also we can use emotions to guide the interview based on the user engagement as it is sensed by this wristband device. Here you have the entire presentation instead in one picture. So you have the interview in which you have the requirements analyst and the user. During the interview, we are able to acquire signals from the wristband about the physiological reaction throughout the interview, and we are able to understand whether the subject is, for example, bored or excited by the discussion. Here, let's take a step back. And let's look at the context that we're dealing with. As I said, we are dealing with product feedback, but we are not collecting product feedback from the reviews. Here the problem is to get detailed information, detailed feedback from users of a certain product that has been developed, for example, for a certain company. The requirements analyst interviews a sample of users of this product and get feedback and try to understand how to improve the product. The requirements analyst then send this feedback to the company that developed the product, and so the product can be improved and can be distributed to a larger set of users. So the idea is like to sample some users to understand how is their feeling about a certain product or certain topics that may be related to the product, and try to improve the product based on this feedback. Here you have some background, like very minimal background about all the studies that have been performed on emotions and engagement. The important thing to remember is that emotions are represented through two main dimensions that are valence and arousal. Arousal concerns the degree of activation, physiological activation of the subject, while valence indicates whether this activation is somewhat related to a positive emotion or to a negative emotion. So, for example, we can have a high valence and high arousal in case of excitement, but we can have high arousal, so high activation, but low valence in case of fear or in case of anger. To distinguish between fear and anger, there is a third dimension that is called dominance, but we are not dealing with that in this context. In any case, as you can see from the diagram, we can distinguish between different types of emotions. Our idea is that these emotions can be used as a proxy for the degree of engagement. So how much engaged is the subject during the interview? So we can distinguish between positive high engagement, negative low engagement in case of boredom, for example, or negative high engagement or positive low engagement. So this is the general idea, using emotions as proxy for engagement and try to identify the degree of arousal and valence of a certain subject. Here are our research questions. First research question is, what range of engagement do users report during an interview? And in this case, we just want to see whether there is a variation of engagement during a certain interview. So is there something actually to see in this interview that we can actually predict afterwards? And to this end, we make an interview about Facebook. We select Facebook as a product with different users. We touch multiple topics during the interview. And afterwards, we ask to report engagement for each question. So we know what was the degree of engagement of the user and whether it was a positive engagement or a negative engagement. The second question is to what extent can we predict users' engagement using biofeedback measurements and supervised classifiers? So our goal here is to understand if it is possible, given that there is a range of emotion, to automatically recognize this engagement. And to this end, during the interview, we collect biometrics with a wristband, as I said before. We derive a set of features from this biometric, and we use them to predict the reported engagement. So we use the data that we got from the user as labels for our feature vectors, basically. And we compare the performance of different machine learning algorithms to see which one is the best one in doing this prediction. To assess, let's say, to respond to this research question, we performed a laboratory experiment, as I said, and we recruited a set of 31 participants from Kennesaw State University. So these were volunteers. They were paid $25, and they were asked to be Facebook users, frequent Facebook users, and they should be involved in the interview for 1 hour. The interview was based on an interview script, so we had a list of predefined questions that were grouped by topic. So 38 questions grouped by topic, all about Facebook. For example, we have the topic of usage habits that is simply how many hours do you use Facebook per day. There is the topic of privacy that, for example, has the question, if someone shared a photo of you in an embarrassing, incriminating, or shameful situation, how would you react? So there are different questions trying to challenge the speaker in certain topics that may be more controversial, also like relationships, ethics, and as mentioned, privacy or money. So the idea is to see whether there is a difference in terms of engagement during the answer to these questions. Meanwhile, we collect the signals through a certain device and the device is Empatica E4. This is a commercial device, but it's mostly used in research in research because it costs around $1,000, I think. And we extract a set of, it can extract a large set of signals, but in our case, we focus on 3 main signals that have been used also in previous studies about emotions, that are the electrodermal activity, the blood volume pulse, and the heart rate. Blood volume pulse and heart rate, I imagine that you know in general what they are, while the electrodermal activity basically is based on a measure of skin resistance, so with a light sensor basically, that gives us some information about, for example, how much you're sweating, basically. That is an indication of how engaged are you or what are your emotions in that specific moment. We performed an experiment, and this experiment involved the requirements analyst, the user, and an observer to monitor the situation and monitor all the data and the saving of the information. The requirements analyst asks the question to the users, and we collect the the biometric feedback, and we translate, let's say, this feedback, these different signals into different features to be used for machine learning later on. After the interview, we ask through a questionnaire to repeat, basically, to look back at the different questionnaire topics, and we ask them how much did you feel involved in that specific topic for that question, and what was the quality of your involvement. And the quality was basically, this was mimicking somehow the two dimension of balance and arousal that we presented earlier. So how much did you feel involved is associated with arousal, how much engaged were you. And what was the quality of your involvement? It was clearly explained to the participant. It was indicating whether it was positive or negative. In this way, we were able to identify a valence score from 1 to 10 and an arousal score from 1 to 10. And these were the labels to be associated to our feature vectors for the machine learning activity. And this is the actual supervised machine learning activity that was performed later on. So we have the different features, we build feature vector, and we try to predict the degree of valence and arousal. In this case, since we are dealing with different scores, we had to create to simplify the problem into classes. So we create positive and negative class, and positive and high and low class for arousal. And we use different classification algorithms, the most common one, from naive Bayes to multi-layer perception to random forest. And now we see the results. Here are the results for the range of engagement. We see from this diagram there is that the whole plot is covered for both valence and arousal. This means that during the interview we were able to trigger all the different types of emotion. Each dot here, each element here is basically an answer given by one of the users. As you can see, there is a higher intensity of dots in the upper right corner that indicates that interviews are positively engaging on average. And because most of the emotions are, most of the more reported values of valence and arousal are in this area of the diagram. On the other hand, as I said at the beginning, the whole spectrum of engagement is covered, because as we can see, we see that that there are dots, that there are elements also throughout the entire diagram. We see also in the bottom table that valence and arousal are in average quite high, so around 7. We remember that it was between 1 and 10, so quite high. And here you see the results in terms of the range of engagement. We see that there is a high engagement for privacy and usage habits. So these are the topics that apparently create, on average, a higher degree of activation, let's say. And while ethics is the one that triggers the most positive engagement on average. So it's a topic that somewhat people like to talk about. Another interesting aspect is that there is a quite large range of emotion for relationships. So it seems that this topic creates more polarized opinion, or it creates, at least in an aggregate way, a large set of emotions. So we're speaking about relation, we have both positive and negative degree of emotion, but quite average, let's say, degree of engagement. Of arousal. Here you have the results for the activity, for the second research question, so for the prediction, and we see that the random forest outperforms all the other algorithms. Here you have a comparison also with a majority class baseline, so with another classifier that selects always the majority class, and we see that we are able to improve in terms of F1 for valence by 22% and for arousal by 46%. So quite substantial improvement. So to conclude, as we say, uses interviews are activities that can trigger positive engagement and a wide range of emotion. Positive engagement, but also covering the whole spectrum. Different levels of engagement are associated to different topics. For example, usage habits, privacy, and ethics appear more engaging with respect to the other topics considered, for example, money. Prediction performance is in line with previous studies with Empatica E4. So we see this type of performance also in the previous study performed by Daniela, Nicole, and Davide on predicting developers' emotion while programming, and better performance for arousal than valence. And this is quite common in these studies because it's related to the signals that are identified by Empatica E4. So they are somehow biased. They are more oriented to discover information related to arousal. To improve this aspect in terms of valence, we need to use more invasive device, but they're invasive, of course, and cannot be used during the interviews. Possible applications are the facilitation of requirements prioritization by the investigating discrepancies between the reported emotions or the reported engagement and the sensed engagement, or by simply checking how much engaged is a user during discussion of a certain feature or a certain improvement. On-the-fly identification of engagement to better see customer analyst requirement solicitation interviews. So not just product feedback interviews, but also requirement solicitation interviews, and knowing the emotion, knowing the engagement can provide us information to steer the interview itself. The approach can also be extended to large scenarios. For example, for A/B testing to compare the feeling about two versions of the same application when low-cost devices will be available, because this requires several users. And we need lower cost device. As I said at the beginning, the cost of the Empatica E4 is quite high and you cannot distribute it to everyone. As conclusion and future work, this is the first study on engagement prediction during interviews. So there are studies on emotions for developers, but this is the first one on emotions collected through wristband in interviews. The study showed that biofeedback and machine learning can be used to actually predict engagement of users when they are interviewed about a certain product. Our future work are related to, first of all, replication of the experiment with a large number of participants, because here we are still in an exploratory phase. So we have recognized that something can be seen, but there is a limited number of participants, and we cannot claim too much, let's say, significance of our result. So we need more experimentation. What we want to do is also to combine with facial expression, voice cues, and other information that can be detected in a non-invasive way to understand the engagement. For example, to focusing first of all on the voice and the voice cues, to have some prosodic cues to understand the degree of engagement and the emotion of the speaker. Another thing we want to do is to explore the emotional dialogue between requirements analyst and user. Here it would be interesting to have a wristband for both the requirements analyst and the user, and to see how the emotion flows from one to the other. And another final interesting thing, it would be to compare the emotional footprint, for example, of interviewers and developers or testers. So what is the emotional footprint of the different software engineering tasks? This is also a research question. So this study opens, in our opinion, a large set of further questions and further studies. So here you have a whole summary of the presentation. So the context that we're dealing with is user feedback during interviews for product improvement, mostly in bespoke software development. The solution is that we are using users' feedback given by a wristband, by a non-invasive device, and we want to predict whether the person is engaged or not engaged. So if they are, for example, excited or bored. The results show that different emotions are associated to different topics of discussion, and we can also predict the engagement with a random forest algorithm that outperforms all the other algorithms. If we want to improve, we need to use either more invasive devices or other cues coming from the videos or from the voice. So if you want to ask me questions, you're free to ask. If you want, I leave you the slides here so that you can refer to it for questions. Thanks for listening.